There it is. Just kidding.
All right, so welcome to the DevOps Speakeasy at the JFocus conference. We have a special interview here with two guests today. So I'm joined by the famous Java performance tuning guru, Kirk Pepperdine.
Hi, Steve.
And also joined by Erik Osterlund. How are you doing, Erik?
I'm good, thank you. How are you?
Excellent, excellent. And we're at the JFocus conference where we are joined by around 1,600 Java geeks who have taken over Stockholm en masse.
It's Geekland around Stockholm Central.
Exactly.
Exactly.
Okay, and I think this will be our most technical interview because what are we gonna talk about?
You tell me. I don't know.
ZGC or
Garbage Collection ZGC, actually, because we have Erik here. He's the lead on the ZGC?
I'm not the lead, no.
Not the lead.
No, I'm one of the geeks.
Okay, well.
one of the geeks. So,
One of the geeks.
you know more about ZGC than I do.
Than
certainly.
anybody.
Probably,
Than anybody.
yes.
So let's start with a baseline for people who don't know what ZGC is. So why should they care?
Yeah, I mean, they don't have to care, but if they care about latencies,
Latency, low latency is pretty good.
Yeah, it's pretty good, and if you're into that, then you might want to care about ZGC. But if you don't care about latencies, then yeah, maybe you don't care.
Okay, so let's baseline assume that we care about latency. We want the lowest possible pauses and other interference with our application, and maybe we've even been referred by a performance tuning guru that we should investigate more efficient garbage collectors. So how does ZGC work?
So the way it works is that we try to do basically everything concurrently. Yeah, I guess that's the main hammer for combating tail latencies, is to make sure everything is running concurrently. And if you have enough CPUs, then we will be able to do everything very efficiently and hopefully without anyone noticing.
Okay, so what would be the typical processor setup you'd want to use with ZGC? Are you looking for like a system which has very high concurrency, like a lot of large-scale systems typically, or?
I mean, there is that, but it's not only people with huge heaps that care about latency. It might be that you care about it anyway, even if you have a small heap. So it's more like the fact that we built a scalable algorithm doesn't necessarily mean that you should only care about this if you have a multi-terabyte heap. I think that it's something that is useful more broadly to a lot of people. Even if you have small heaps, that it's still useful to not have to worry about latency. It's just a factor that you don't really have to think so much about.
Yeah, and you do a little bit of performance tuning.
A little bit.
So how many of the folks who you're doing performance tuning and optimizations for have latency issues?
Just about all of them have latency issues. Yeah, I think that's a standard problem, especially like tail latency issues. We have a lot of people that are focusing on making sure their latencies are within a tight band, and garbage collection traditionally has been disruptive to these types of measures. And I've really been looking forward to working more with ZGC because we have it. I'll do it the Canadian way, ZGC. Working with ZGC because it's had these guaranteed pause time limits that are very short, and it really helps to tighten latency on applications. So it was 2 years ago, the last time we had live JFocus, we presented a pause time model for microservices that was based on GC latency, and expected latencies just due to pauses, depending on how long your microservice chains were. And you get into some relatively short chains, and you can see that all of a sudden your latencies are creeping up really, really high, almost approaching a second when you get into chains that are length 100. And we know many services are using chain lengths of 500 or more. So you're seeing all of a sudden multiple seconds of latency simply because of the pause characteristics of the systems that you're running on.
Okay, yeah. So that sounds like that. Like performance-wise, if you're running a high-performance application, those would be unacceptable pause times.
Oh, those are almost unacceptable pause times for even not high performance applications at this point in time.
Having your application server take a second.
You have to have now really creative, really creative web designers who are really good at hiding latency from you, right? So they can hide latency from you, the more you don't notice it.
Okay, and what state is GC in right now? Is it?
What state? You mean the generational or the
Well, this is exciting news, right? Because we have a non-generational version of ZGC, which basically means you just got like wide open on memory. It doesn't differentiate between young and old data.
Okay.
But there's some advantages to using this behavior in terms of the optimization, and he's going ahead.
Yeah, so we're working on a generational version where we separate the storage of old and young objects so that we can more efficiently collect the young generation.
Yeah.
So that's what we're working on at the moment. And what state is it in? Well, it is working relatively well, but we're also trying to hide the fact that we are generational as much as possible so that we don't expose too many things that the users have to tune that are very difficult to understand what the correct values would be.
Yeah. So I think, again, like when you're looking at performance tuning people's applications using other garbage collectors, how often do people get the flags right for the garbage collector in terms of?
It's a real problem. As a matter of fact, my talk here for JDConf on Thursday is going to be just on studying how wrong people get flags. Just case studying it, right? You know, spoiler alert for the talk. It's like use defaults as much as possible, and I think in this case, we've had this conversation. It's an exchange of my experiences in the field back to him, and he can take away these ideas and hopefully use them in a way that helps people not have to understand what these things are, right? So we're just talking about a simple idea called tenuring threshold. Well, it's simple for us, right? But it's a highly nuanced topic, and the data is, sometimes it's the only piece of data I need in order to be able to tune a collector, right? And by having this type of conversation with them, hopefully you can take that information back and say like, wow, okay, kick me out of a job, right?
That's what I'm trying to do.
That's what you're trying to do. Perfect.
Yeah.
or perhaps with newer and more complicated garbage collectors, this produces even more work for you.
Yes. I've always been hoping to be out of a job, to move on to other fun things, but yeah.
I think performance is something you're always chasing but never achieve. Right?
Yeah, that's unfortunately a fact of life. You guys have been writing garbage collectors for how long now?
Well, actually since my bachelor degree.
Since your bachelor degree?
Yeah.
Yes, there you go.
Okay.
I have a fun question for them though, right? Because my daughters, when they're going to school, the kids would come to them and say, "So what does your dad do?" And they always took delight in saying like, "Oh, my dad specializes in garbage collection."
Yeah.
So.
Yeah, my dad occasionally asks me what I'm doing, and he's like, "Are you still doing garbage collection?" I felt like you could do so much more. Yeah, it definitely happened.
Yeah, I could see explaining to your parents what you do for a living could be challenging. But okay, so for us geeks who are who look at your job as being highly prestigious, how would you become a full-time garbage collector?
Sorry.
So how did you end up taking a career in compiler and garbage collection and like these sort of advanced computer science topics?
It actually started with a phone call with my brother. He had taken some random course at the university about programming paradigms, and he was excited to talk about functional programming as completely superior because you had these pure objects and had side effect free functions that you could do things in parallel. And I was like, if only you had a garbage collector that traversed the heap and figured all of this out automatically, you might be able to integrate something like that into an object-oriented language. And I built a garbage collector to do exactly that. And I think that's when it started, and it all went downhill from there.
Yeah, apparently it's gone downhill, but benefited the greater performance tuning community. So
yes,
we appreciate your sacrifice.
Absolutely.
Thank you.
He sacrificed his life for.
Okay, so just to kind of wrap up, anything which for people who want to get started with ZGC, what are some good resources that they should look out for?
Put me on the spot there. There is a wiki page somewhere for ZGC. I don't remember the URL, but maybe you can put it in.
Okay, we'll put that in the show notes. Good point there.
Yes. I think that's probably the most useful resource. It's the few things that you need to know about it are on that wiki page. And otherwise, if you have any questions, there is also a mailing list. ZGC dev at openjdk.java.
Okay, very nice. So the OpenJDK mailing list as well.
Yeah.
Yep.
GC Toolkit.
GC Toolkit.
Right, which we open sourced in last summer. And it supports the non-generational version of ZGC. And perhaps a good way of understanding generational ZGC is to help us support ZGC inside GC Toolkit.
Nice.
And that's
an open source project?
Open source project, Microsoft GitHub.
Nice. Okay, so thanks very much, Kirk and Erik, for joining me for the DevOps Speakeasy. You can watch more great interviews on our YouTube channel, and hope you guys enjoy the rest of the JFocus conference.
Thank you, Steve. Enjoy too.